All right, good morning, everybody. Welcome to Stem Cell Talks. Thank you for the introduction, Zoe and the organizers. Thanks for the invite as well. It's exciting to be back giving the Stem Cell Talks 101 presentation again. My name is Wes. I'm a graduate student here at the University of Alberta. I'm doing my PhD in the Department of Psychiatry, and I work primarily on mental health disorders, specifically schizophrenia. So I don't actually work with stem cells in my day-to-day activities, but this is an event that I've been involved with for many years, and I certainly have a personal interest in stem cells and think it's a really fascinating topic. And so I'm excited to be here giving an introductory talk on them today to all of you. And I hope that you guys learn a lot. I hope that you have fun listening to some of the talks and doing some of the activities. I think there's a lot of cool stuff to learn about stem cells, and they have a lot of potential to impact our lives down the road. So to start with, I thought I'd maybe just share a little bit about why I think it's such a cool scientific topic. I'm passionate about many aspects of science, but this one in particular I think is really cool just because when you look at the role that stem cells play in human development, or in the development of any organism really, but in this case we'll be talking about human development, that we start from just one single cell. And throughout the lifespan, that cell divides and grows and changes and differentiates into everything that we are as an adult. So, you have teeth and eyes and fingers and hair. And obviously within, humans, there's anomalies, and we each have our defects and different things about us. But that pattern for developing a human body is sort of, the fundamentals of it are the same. And we all end up in the same place with more or less the same features, even though we're each unique. And I think the line between those 2 points, that single cell to us as an adult, is so mystifying, and so it's like a beautiful orchestra that is played out over the course of a lifespan, because there are so many moving pieces and so many different notes and sounds that get us to where we are as an adult. That is just really wonderful for me to try and think about and learn about as we hear more and more about stem cells and human development. So I wanted to talk a little bit about why are stem cells important? Why are we having this event today? Why is it important that you guys hear about them? And the first answer I would give to that, there's two answers. One is that I think from a scientific perspective, the medicinal and therapeutic potential of stem cells is immense. I don't want to be too broad reaching, but I think some of the excitement and hype within the scientific community is because in so many different diseases and injuries and things that happen to people, we can imagine a role where stem cells might be helpful to us in treating those conditions and in helping those people. That's not to say that it will be useful for all those in the end, but the footing is there to stand on and say, hey, maybe in Alzheimer's, maybe stem cells could be helpful for us. Maybe in stroke, stem cells could be helpful for us. Maybe in burns in our skin, stem cells can be helpful. There's so many different things that you could imagine a purpose where stem cells are able to help you. And so that's where a lot of the hype in the scientific community and in the medical community is being generated for stem cells because of this massive potential. The second aspect that really I think is interesting for stem cells is not just the pure science, but the way that the science has been communicated and shared with the public. And this is an issue that's not unique only to stem cells. There are many scientific concepts and theories and ideas that have been poorly conveyed or misrepresented or communicated poorly to the public. And I think stem cells is certainly one of those. And there's a lot of misinformation out there, and there's a lot of people that are piggybacking on the hype and the hope, as you can see in this Time article here, the hope, the hype, and what it means for you. There is a lot of hope and a lot of hype, but some people choose to kind of piggyback on that and abuse it, and it makes it difficult to discern what's real about stem cells and what we should be excited about and what's maybe not proven yet and we should temper our expectations on. So I wanted to share a few examples, just the way that stem cells have been portrayed in the media. So here you can see, Peyton Manning or some other athletes that have used stem cells to have miraculous cures for a neck injury. You can also see a lot of beauty products popping up here that are suggesting that they use stem cells are involved in their product to help you. And I can even just posting these, I can imagine these commercials, saying, "Hey Wes, if you buy our stem cell rich moisturizer cream, you're gonna rub it on your face, and it's gonna make you look 10 years younger and more beautiful." And that's not wrong to desire that. I'd love those things, but is that based in fact and reality? Is it grounded in science that those products can do that? And if not, that's concerning, because people are marketing and promoting these products and obviously making money off them. And that's not something we like to see when science is sort of abused to make profit or make money, when the science is not really there. And I think there's a lot of that going on right now with stem cells in the world. And part of the reason we want to have an event like this and have people learn more about stem cells is so we can be critical thinkers about stem cells, and when they're presented to us, ask, does that claim really check out? Do I think that that's a reality? And do I think that it's backed up by the science behind stem cells? I don't want to be entirely pessimistic. So you can see some of these articles that come up at the end here are some bigger magazines, The Economist, Time Magazine. Cancer and stem cells, the connection that could lead to a cure, the coming revolution in stem cells. I think there is a lot of excitement, and you should be hopeful and excited. That's not wrong. I think we just need to be realistic and be patient, and good science takes time, and not getting ahead of ourselves in terms of the claims that we're making, especially when we're trying to offer them to people that could be sick, could be desperate, could be people that are spending money that they really need on things that maybe won't actually benefit them. Okay, so what is a stem cell? There's two real defining characteristics that I want us to cover and remember throughout the entire day. You can go back to these, that are things that define what makes it a stem cell. The first one being self-renewal. So with self-renewal, a stem cell can split itself into two completely identical stem cells. So it means that it can kind of populate and replenish this group of cells that is really, it's just the one cell. It's a stem cell that can continue to divide and replicate itself. So there's always this pool of stem cells, even if some of those stem cells were to leave and become something else. And that's the second step of this, is called differentiation, which is often spoken about hand in hand with potency. Differentiation means that a stem cell can differentiate into some type of more specialized cell or mature cell. So an example would be, a stem cell that goes and differentiates into liver cells, or skin cells, or hair cells, things that are a more specialized, sort of unique type of cell from the stem cell. People also talk about this in terms of potency. So stem cells have great potency, and the potency means that they can become many different types of specialized cells. So if we think from that very first cell during when the egg is fertilized and the zygote is sort of there, that cell, it has the greatest potency of all cells, because it will give rise to everything that you are as an adult. And what we see is that throughout the lifespan, you have stem cells that become sort of less potent, but still have a certain degree of potency. So they can only become certain cell types, maybe 2 or 3 different cell types, as opposed to all of the cells of the human body. And the information for that is encoded in those first cells that give rise to who we are as people. So a fun fact, stem cells were discovered by James Till and Ernest McCulloch, both who are Canadian, back in 1961. And to give a far more descriptive and expertise-backed description of these two properties, there's a video here that is narrated by Dr. Till.
Bone marrow contains many different types of cells, several of which have specialized roles in the blood. In the early 1960s, it was shown that if bone marrow was taken from one mouse and transplanted into another, rare and specialized cells could travel to the spleen, where they would divide and form small colonies. These colonies contained a mixture of different blood cell types. Incredibly, when these colonies were removed and retransplanted, these rare cells formed new colonies in the spleen of a second mouse. These experiments revealed two defining properties of a stem cell. First, a stem cell must be able to self-renew. That is, it must be able to divide and give rise to more cells like itself. Second, it must be able to differentiate. In other words, it must be able to divide and give rise to specialized cells. Since these early experiments, many different types of stem cells have been discovered, and this general definition applies to all of them.
Awesome. So yeah, that gives a description just again of these two basic characteristics of stem cells. And obviously there's more specialized features to them, but one, that they have the capacity for self-renewal, and two, that they have the capacity for differentiation. All right, so at the end of the video there, this did lead into sort of the question of where do we find stem cells? And there are a variety of different types of stem cells, some of which we've already sort of addressed. But the first one I want to talk about is adult stem cells. So stem cells are not something that you only have as a fetus and an embryo and as a child. There are stem cells in you and me right now, even in your parents and your grandparents. They have stem cells, even though the characteristics of those cells do change with age and time. So if we were looking for adult stem cells, one that was mentioned there was the bone marrow is a very stem cell rich sort of area, but all throughout the body we can find populations of stem cells. So the brain is a big one. The blood is in the bone marrow. Our spinal cord, our eyes, pretty much anywhere you look throughout the body, you're going to be able to find, niche populations of stem cells that give rise to rejuvenating and replenishing the cell supply in that area. The second one is embryonic stem cells, and embryonic stem cells are from right after a egg is fertilized and a sort of a zygote or an inner cell mass forms. There is a lot of stem cells, and they have a great potency. And that's the reason why people are interested in embryonic stem cells, is they're the most potent cells you're going to get your hands on. The issue with embryonic stem cells is a big one that we'll talk about later in terms of ethics and legal considerations, because people view embryonic stem cells very differently and different sort of religious and legal perspectives on the formation of life and things like that, and when it's a person in development, that are really important to consider when we talk about using these stem cells in therapies or in research. And we'll talk a little bit more about that later. One of the newer types, I guess, of stem cells that's been discovered that has a lot of potential is called induced pluripotent stem cells. And the idea here is that rather than taking a stem cell and giving it a set of instructions to differentiate into, say, skin or bone, you take a sample from something like the skin or the bone, you apply a certain variety of sort of chemical and signaling factors for this mature specialized cell type that will revert it back to a stem cell. So this kind of gives it more potency, back to a more potent state. And so pluripotent meaning many potencies. And the advantage here really is just that a lot of stem cell therapies that people are thinking about are to transplant tissues and cells into people that might need them. And a major issue you encounter when you do that in any type of transplant is called tissue rejection. So if I came in and I had a liver issue, somebody donated some cells. When those cells are given to me, my body can reject them and attack them because they recognize them as sort of a foreign material with a different genetic profile, and they don't like these foreign materials in the body, and so often they'll reject them, and we have to do a lot of things to help people to get through this period and make sure that these organs are not rejected. So the advantage of using induced pluripotent stem cells is it's your own material, it's your own cells that you're using. So I came in, I'm having some medical issues that need some kidney cells. They take maybe a little scraping off of my skin, or they take it from my blood. They put those cells into a dish, use them to make sort of induced pluripotent stem cells that can then become different cell types that you could use for therapies. And so there's a lot of excitement around using these IPS cells, as they're called, induced pluripotent stem cells, to circumvent some of the other issues that we see with stem cells. All right, we have another video here to describe induced pluripotent stem cells.
Most of the cells in our bodies are not stem cells. For example, blood and skin cells have become specialized to perform a specific function in the body by a process known as differentiation that's normally not reversible. However, if some adult cell types are taken, grown in plastic dishes, and given specific genetic instructions, over time, a small number of these cells will reverse from their differentiated state and develop the ability to redifferentiate into any cell type in the body. This newfound ability is known as pluripotency, and therefore these cells are known as induced pluripotent stem cells, or IPS. The creation of IPS cells from individual patients may one day allow us to develop replacement tissues that are a perfect genetic match to the patient. In addition, the creation of IPS cells from patients with specific diseases will allow scientists to develop new drugs to treat a wide variety of disorders.
All right, so the end of that video segued nicely into what are the potential uses, and really I think the better question is what aren't the potential uses? And again, you want to consider things that are grounded in science and backed up, but when we speculate about stem cells, I think there's a great variety of things we think that they could be helpful with, and a few of them were mentioned at the end of that video. So a big one is cancer. So cancers obviously are a massive issue in society, and there's a wide variety of types of cancers. And while our therapies and treatments are improving, we're still struggling to treat a lot of cancers, and they can be terminal. Many cancers are thought to be arise from malfunctions in stem cells that are constantly dividing and growing without sort of any breaks or stop signs to prevent them from doing so. And so by studying stem cells, we can learn more about cancers and how we might be able to prevent them using different signals to direct and stop those cells from growing. The other big one I'll mention here is drug testing. That was mentioned at the end of the video. So for two reasons. One, for a safety considerations. So if you take some stem cells from people, you could grow them into a bunch of cells. So say you wanted to look at whether your new drug that helps with a heart failure is safe to use. You could take a bunch of heart cells and grow them, some stem cells, grow them into heart cells, treat them with this drug, and then see how the cells respond. And you're doing it in a dish, so if something goes wrong, it doesn't really matter. You can stop using the drug and not use it in people because you found out that it's unsafe. But it just gives us a medium to test drugs that's not directly in people, which puts those people at risk. The second aspect would be, as the video mentioned, in really rare diseases where it's difficult to test therapies and ideas about how to help these people because they are so rare and we see them so infrequently. So you have somebody with this 1 in a billion disease, you could get some cells, take a sample from them, stem cells, and then grow a bunch of those cells and test a variety of different hypotheses and drugs and therapeutics to see how you could help them, even though you have very few people that actually have that disease or condition. The last one I'll mention, so I talked a bit about the start about beauty products and the breadth of beauty products that promise using stem cells for some degree of efficacy to do certain things, and many of those being, I think, misguided or maybe not backed up by science, but I'm pretty sure that the lengthening eyelash is one. There's actually a product that has been shown to be effective using stem cells to lengthen your eyelashes. You'd have to look it up and critique yourself. It's been a few years since I looked at that, but there are developments that are coming. There are products that are available, but in a wide variety of ways, I guess. All right, so we talked a bit more speculatively about the potential uses, but what are the current uses? And the reality is there is currently very few. So there's not a lot of products out there right now that are based on stem cell therapies that are effective or proven to be effective. That number grows every year, I think, as there's a massive amount of research being conducted on stem cells, and some of them are very, very promising. But if you're thinking about it as though there's widespread stem cell therapies out there, that's really not true. If you get the perspective, I guess, that there's widespread stem cell therapies out there, I'd be considering more whether those are founded again in science, because if you go on the internet, you can look up a lot of medical clinics that promise using stem cells to do things that are pretty bold, curing cancer, curing strokes, curing terminal illnesses and diseases. And right now, very, very few of those have a sound basis in science or backed up by science that they are effective. Okay, so this graphic here is just showing sort of I wanted to get a picture for you guys of the scope of research, and maybe it's reflective of the excitement within the scientific community studying stem cells. And so this is showing, studies sort of throughout the world and people that are hosting these stem cell studies. And this was from, I think, 2 years ago. So these numbers may have changed. But you can see many in Canada here, tons in the US is a massive research engine, many in Europe and China, but really all throughout the world. People are studying stem cells in so many different contexts because there are so many types of specialized cells in the body to investigate and see if you can create them using stem cells and try and help people. This graphic here is from a website called clinicaltrials.gov. Clinicaltrials.gov is a website that would track a clinical trial. So anyone who has a clinical trial will register it here, and people can follow along, or scientists can follow along and look at the outcomes and look at the results. And I just wanted to show the search term. You can see studies found for stem cells. There's almost 5,800. So a lot of clinical trials that are ongoing currently looking at the ways that we can use stem cells to help people. What's holding us back? So we've seen, I mean, there's so many potential uses, but there's currently very few. And what's the disconnect between those two things? And there's a lot of obstacles right now that people are working on trying to figure out in terms of using stem cells. So this is not a comprehensive list, but a few of them being to generate enough tissue. So taking one stem cell from a person and differentiating it into one cell type is one success, but then you need to be able to generate enough of that tissue for it actually to be meaningful. So if somebody has a burn on their arm and we're trying to generate a skin graft, one cell is not going to do. We need, billions and trillions of cells. So being able to sort of ramp up that production or the scale of cells that you're able to create is really important in terms of making these therapies meaningful. Secondly, they need to differentiate into the right type of tissue, and this is really difficult getting all of the right factors in place to make a stem cell turn into the type of tissue that you want. Some tissue types are easier than others, so you think about an area like the brain is extremely complex and interwoven and intricate. So just dumping a bunch of cells in there and telling them to differentiate is not going to be helpful, and in fact would probably be very detrimental. You need to be very specific in which cells are turning into which type of things. One horror story I know about this sort of example is somebody that was getting a treatment, I believe, for their eyelids, some type of cosmetic therapy, and had some stem cells implanted in their eyelids, and they end up differentiating into chunks of bone. And so you can imagine, I think, how painful it would be to have a bunch of chunks of bone developing and growing in your eyelids. And so you have to be really careful in terms of the treatments that you're providing and making sure that you're targeted and specific in getting those stem cells to become the things that you want them to be. The last one's there, survive after transplantation. So you need to make sure these cells actually survive and live, and then that they function in the place that and they get to the place that they're supposed to go to. So cells just entering the body and then dying off is not typically useful. There are uses for that, but you want them to survive and to function. And lastly, of course, that you want to have no adverse side effects. We don't want to be providing treatments to help people that are in fact not helpful or hurt them in other ways. And so looking for adverse side effects is a big part of evaluating stem cell therapies at this time. And lastly, I'll just give a brief introduction to some of the ethical issues that surround stem cells. So there are many different religious perspectives on stem cells, particularly when we look at embryonic stem cells. And this is about how different religions and different people and different populations look at the formation of life and things like that. And so these are considerations that we have to make when we look at using stem cells and different types of stem cells is what we think is appropriate and what we think is safe and is respectful. There are legal considerations that vary by country. So Canada, I think, is for the most part one of the more restrictive in terms of the regulations for stem cell use. We have very little, if any, embryonic stem cell use here in Canada for research. And if you want to use them, you really need to have a sound backed up reasoning why you have to use that type of cells and you can't use any other type of cells to conduct your study. So we're fairly rigorous in terms of or restrictive in letting people use those, but other countries are far more permissive. There's also ethical considerations for donors, and this really, in a sense, is their biological property. If you're taking a sample of my stem cells and using them, you need to make sure that some of the basic principles of consent and things like that are in place to make sure that you're considering the donors and their well-being as well. Each of these ethical issues, I think, and all the science we've already talked about, I imagine you're going to discuss in far greater detail throughout the day with experts who are far more qualified than myself. So I really wanted to just give a primer on some of these basics of what stem cells are what we could use them for. And I really encourage you guys to just be creative today and think about and brainstorm, things that matter to you, and think about how stem cells could be used, because there are a wide variety of potential uses, and some of them, I mean, we may never have heard of before. There's always new ideas, and maybe it's you that is the one who's going to test them and prove it. So yeah, thank you for listening. If you have questions, you can get Zoe to send them to me, or you can answer them there in your class. And I really hope you guys get to learn a lot today. I hope you have fun, and good luck learning about stem cells. Everyone be safe, wear a mask, wash your hands, and thanks for having me.